Hey, Deja. Here everybody comes. Great to see you all today. Remember to turn your cameras on, at least at the very beginning of class. Thank you. Wonderful. Hello, hello. All right. Did you guys all have a good weekend? Ready for Monday? Are we ever ready for Monday? Sometimes. Sometimes. All right. Anybody have any questions before we get started? Hold on one second here. All right. So I didn't get any notices. Remember, if you know that you're going to be missing class, let me know. Because if you let me know, it's counted as an excused absence. If you don't let me know, then it's just an absence. And in my class, I don't take off points if you're not here. So if you have an unexcused absence, it's not a big deal. But I do bump your grade up a little bit at the end. I'll add a few points if you're here most of the time and your absences are excused. All right, I'm going to make sure that the recording is on. I believe that it is. Yep. All right, so we will go ahead and get started. I like to start right away on time. Ken, you've got some balloons flying through the air there. That's nice and colorful. All right. All right. And a couple things. If I ever forget to turn on the slideshow, let me know. I always have one of these presentations like this one that I am going to show you always. Every single week, there will be one of these. It will never be just me. So if I ever forget to turn it on, let me know that right away. And let's see here if we've got any. No chats yet. Okay. Remember, if you have a question during the lesson, if you can ask me right away. You can either say it or you can type it. Either way is fine with me. I prefer discussion. So I prefer when we talk to each other. Just a little bit more fun, I think. All right, let's begin then when we are talking about science. So before we get into the what is science part of our class today, I told you guys that I would give you a little bit more information about what I mean when I say use good grammar, good spelling. So today we're going to talk about the grammar rules for my class. Now, obviously, your English teacher is going to have more rules than your science teacher and math teacher would have. But I'm going to tell you what's important to me, because very soon I'm going to start taking off points for spelling and grammar errors. Not a lot. It won't be a lot of points. This is not an English class. I'm not going to take off a lot. But I think it's really important that you learn how to use proper grammar when you're doing school subjects. And I notice a couple of common errors that students make. So I'm going to spend a little bit of time today talking about what those errors are. Now, there's a lot more to good grammar than just the things I'm going to talk about, but this is what I'll be looking for. This is what I'll be taking points off. And the question becomes, why does grammar matter anyway? Well, proper grammar can actually save lives. Let's eat, Grandpa. Let's eat, Grandpa. Makes a difference between whether we're inviting him to dinner or having him for dinner, right? And look at this one. A panda eats shoots and leaves, unless, of course, it's a tactical panda, when then it eats, comma, shoots, comma, and leaves. All right, enough silliness. Always, always capitalize the first word of every sentence. Now, again, this only is the lessons that you have to write out answers to. When we're talking here, anything goes. You can use text speak in our live classes. When you send me a Canvas inbox message, you can use whatever text speak you want. It's only when it's going to be graded in my class that these are the rules that I want. I want you to always capitalize the first word of every sentence. Always capitalize the personal pronoun I. No lowercase i's when you mean yourself. And then we capitalize the names of specific people, places, and things. So I want capitalization. That's number one. I want sentences, full sentences. Don't just give me 2 or 3 words when you give an answer to a question that's going to be graded. give a full sentence. So a sentence is a group of words that expresses a whole thought, a complete thought. Every sentence has two important parts to it. It has a subject, that's what the sentence is about, and it has what's called a predicate. Usually the predicate is a verb, so we can say it has a subject and a verb or an action word. So here's a couple of examples of full sentences. In these, the subject is in red. The flower is what the sentence is about. And what's the verb? The action word, bloomed. The flower bloomed. Capital T, period at the end. Bob painted. The subject is Bob. The verb is painted. The girls on the team, that's the subject. We're all good students. All right. I want you to not ever begin a sentence with the word because. It's really best not to. There are a couple of situations where it's okay to start a sentence with because, but really not when you're submitting homework. Now, I know there are some of you who will want to know when those times are, but so here they are. Here are the rules. You can start a sentence with because when you have two parts to the sentence, two clauses that are connected by a comma. So when you can use the word since or because at the same time. Since the plant didn't grow, I hypothesized there was not enough water. That would be a time when you could start it with because the plant didn't grow. The other time that you can do it is when you're speaking to someone, when you're having a conversation and they say to you, why didn't the plant grow? And you can say, because I didn't water it. So when we're talking here in class, it's fine to answer one of my questions with because. But when you're turning in homework, it's just best not to. Don't use the word because. And then punctuation. Sentences always end with some kind of punctuation. They either end with a period or a question mark or an exclamation point, almost always. Okay, now again, there's more rules, but these are the ones that I want you to follow for my class. That's pretty easy, really. Capitalize the first word of each sentence and the pronoun I. Use full sentences that do not begin with the word because, and end your sentences with punctuation. That's pretty easy, right? Not a lot of rules. So I will start very soon taking off points for assignments. Now, what do I mean by that, taking off points? Well, if a question is worth 5 points, I might take off 1/4 of a point, okay, for a sentence that's not right. I'm not going to take off 10 points for a 10-point question. All right, so here's a couple of examples. You guys tell me which is the correct sentence, the first, the second, the third, or the fourth. Yep, the first. I used red beans for my experiment. It starts with the uppercase I and it ends with a period. And it's a full thought. It has a subject. Subject is I. And the predicate or the verb is used. I used. That would be a complete sentence. How about this one? Which is the first, which is the correct sentence, first, second, third, or fourth?
Fourth.
The fourth. Actually, I think I have the second one. I think I did that. That's what supposed to say because science is my favorite subject. All right, I made a mistake on that. So the second, oh, no. The second one has a lowercase I. Yeah, there it is. I see that. So yes, the fourth one, it has a capital S for science. It has an uppercase I for when I say I do my homework. It has a period at the end and it's a full sentence. It gives you a complete thought. Excellent. Anybody have any questions about my grammar rules? All right, I'll remind you a couple times, then I'll start taking off points. All right, so we do have a couple of jokes. What do you call a tube that just finished 12th grade? A tube that just finished 12th grade, sorry. I was looking at James's fourth right there and said it. Any guesses? A tube that just finished 12th grade is called a graduated cylinder. You got it, James, just a little bit behind me. It is called a graduated cylinder. What did the science book say to the math book? You've got problems. This is one of my favorites right here. The human body is primarily composed of carbon, hydrogen, oxygen, and a little bit of sodium. So basically, we are 100% nacho. Na for sodium, C for carbon, H for hydrogen, O for oxygen. We are 100% nacho. All right, and this one is very applicable here. What should you do when no one laughs at your science jokes? Keep trying until you get a reaction. All right, excellent. So the more you react, the better my jokes will get. The less you react, I'll just keep trying, keep trying, keep trying. All right, couple more important things. Please make sure you are getting the announcements to your email or your parents' email. Make sure I don't have the here's how to check on there because I have it in the lesson now. But make sure that you are getting the announcements. There is a lesson in that course information at the top that says how to verify your email address. Make sure that you have done that. And this is really, really important now. When you send me any kind of message through Canvas inbox, let's say you have a question about a quiz. Don't just say, I have a question about the quiz today, because then I have to write back and say, what quiz do you mean? And you say, the one that was due today. And I say, yeah, but remember my due dates are flexible. So which one are you talking about? And then you say, okay, 2.3. And I say, all right, what's your question number? You see how it can take a really long time for us to get an answer to you. If you start off by telling me either the page number in our book or the name of the lesson or the Learning Check question number, and give me as much information as you can about why you need help, why you don't understand that, then you can get an answer as quick as possible. All right? Anybody have any questions about that? I will remind you from time to time when we do that. All right. Now I have hold on a second here. Hold on. Okay, there we are. Took me a minute to find something I'm looking for. Okay, I have a program that I will use from time to time with you guys. I'm going to use it today to help us get acquainted. Now, just like with Kahoot, you'll need either a phone or a tablet or be able to split your computer screen. Or for this one, you can just go to that one and then come back to this one. So open a new window in your computer. That will be fine. The name of this program is Mentimeter. You don't have to add any of your personal information. You'll just answer questions on this Mentimeter. So let's see here. The code that you're going to use is, hold on, it's loading for me. I'm going to type it in the chat box for you so you can see that. It is 4733418, and you go to menti.com. There you go, menti.com. And when the code comes up, you put in your when it asks for a code. So I'm going to show you on my phone what I mean. I'm going to type in menti.com. MENTI.com. Okay, it'll look like this. All right, somebody answered that one already. You would then type in 4733418 and using just one word, name something that makes you happy. I'm going to drag this over so that you guys can also see. You should be able to see this on your own screen as well, on your phone or your tablet. But I've got it right here for those of you who are having a split screen. All right, using just one word, name something that makes you happy. Oh, ice cream, be careful not to highlight like that. That makes it hard to see. All right, Rubik's Cube. I know who answered that one. Alistair has a record timing for doing a Rubik's Cube. How fast is it, Alistair? Like 5 seconds, 10 seconds? 5.17 seconds. Yeah, that's pretty cool. All right, anybody else? Okay, we only have 2. Any of the rest of you want to type in your answer? See, when they're highlighted like that, they're hard to see. Art. All right, 4-7. I'm gonna get in here. 3-3-4-1-8. All right. All right. We have chickens, Rubik's Cube, snow globes, dogs, art, ice cream, school, and chickens. Guess who put in school? Yeah, because it does make me happy. How do you not highlight? I'm not sure. Let's change slides and we'll see. I'll see if I can figure it out on my phone. This is just a new program. I played with it a little bit last year, but I really liked it. So I think we're going to use it more this year. All right, so let's go to the next one. Here's your next question. What is your least favorite food? Let's see here. Can anybody see there where it's where it highlights, how you turn off highlight? Sometimes you guys are better at figuring it out than I am. Asparagus, garlic, peppers, tomatoes, tomato soup. That's specific. Brussels sprouts. I used to hate Brussels sprouts. Now I love them. All right. Mostly vegetables there. That's interesting. Isn't that interesting? Vegetables are so important. So good for you. Okay, let's do our next one. Using just one word, name something that drives you crazy. You drive yourself crazy? Somebody drives themselves crazy. Brother and sister, there's always siblings on there. Trust me, someday your siblings will be your best friends. Right now, they probably drive you crazy. Nails on a chalkboard. Yeah, that's a hard one. A lot of people have trouble with nails on a chalkboard. Or the feel of styrofoam. Is that another one that kind of sets your teeth on edge? All right, next question. Describe yourself using just one word. One word. Me. Awesome. I love that. Love the confidence in awesome. Creative. Average. Artist. All right. I'm looking forward to there are some lessons that you'll have a choice and you get to do a little bit of artwork in the class. So I'm looking forward to seeing those from the artist and the creative person in the room. Awesome. All right. So Aaliyah, did you figure out how not to highlight?
No, but it doesn't look like it's highlighted on your screen.
No, it doesn't. It doesn't. All right. Well, interesting. I couldn't see how to make it do that either. So, all right, here's our next question. If you could have 25 hours in each day, what would you do with the extra hour? See, it's getting bigger because more people are saying it. The more people say the same word, the bigger it gets on this. So we have a good bit of sleep. 3 people want to sleep and 1 wants to eat. Walk my chicken. All right, Hannah, you're the one with chickens, right? Or is it Beth? Beth, you have chickens and you take them for a walk? So do you have a little neck, a little harness and?
Yeah, I have a harness and a leash for it.
Well, how adorable is that? You should send us a picture. Send me a picture of your chickens on a leash and I'll put it in the next class.
Okay.
That's pretty cool. All right, walk my chicken, sleep and eat. And give one step in the scientific method. We haven't talked about that yet. We're going to today. Anybody know what one step in the scientific method is? No reason you should know yet unless you've had it in another class. Yeah, test is one step. Brainstorm, collect data. Anybody else? Any other thoughts? Ask questions. Good. Good. You guys are getting it. Excellent job. All right. Safety. Yeah, we definitely want to be safe. Some of these are not official steps in the scientific method, but they're important parts of scientific procedure. All right. That's it. That's the end of our presentation. So that's just a little way that we can get acquainted. Each class, I'm going to have just a couple questions so that you can, share a little bit about yourself. All right. Now, last week we were talking about how octopuses can open jars. And I told you guys that I would try to get a video of one. So I found one. Here is an octopus opening this jar lid. Right off. Unscrew that jar right off. And an octopus can even open a jar from the inside. So there's an octopus in that jar. She's going to screw the jar lid on. Let's watch this. There's no sound for this one. Now watch what the octopus does. That's all done with those suction cups that they have on their legs where they can suction it and then twist. Watch the arrow as it moves more and more. You can see that octopus inside kind of spiraling as it twists that jar lid. There it is. Gets right out. Pretty cool, pretty cool. All right. What do you guys think of when you hear the word science? What do you think of? Anybody? What do you think science is? If you had to define science, what would you think science is? Science is a way of understanding the physical world. And what's that way of understanding based on? It's based on evidence you can observe, experiments or tests, reasoning, and then repeatedly doing the testing. Hannah, that's a good answer. Learning about the world. It's about the physical world. It's about the things that you can see and touch and interact with. It's not about things like hopes and dreams, right? Those are not part of the physical world. They're real. You know, your hopes and dreams, the things that you want, those are real. But science doesn't study those. Science studies the physical world. So, observable evidence. What do you think of when you hear the word evidence? It's a good definition of evidence. Reasons. Yep, good. Proof. Good. Evidence often leads to proof. That's for sure. A source to back up your answer. Good. Put all those together. That's a really good definition. Basically, it's something that gives us a reason or some proof that something else is present. Something else is real, that our answer is valid. And so we can back it up. Excellent. So that's evidence. What do we mean by experimentation? What's another word for experimentation? You guys can talk. It's a lot faster than waiting to type. We have a small class today too, so you don't even have to raise your hands. You can just talk if you want.
Trying new things.
Yeah, good. Trying new things. Yep, experimentation is trying something. A test of some kind, right? Trying things to get a result. Good, good. Reasoning. So that goes back to the thinking logically kind of thing. And then trying your test over and over again, repeatedly, to make sure that you get the right answer over and over again. All right, so I have a couple poll questions for you guys about questions. Let me pull these up. All right. Where did it go? Okay, here we go. Here's your first question. Can science explain what a manatee eats? Remembering what science is. It's a way of observing the physical world based on observable evidence, experimentation, reasoning, and repeated testing. How many of you think yes, science can explain what a manatee eats? How many think no? Got a couple yeses. How many no's? All right, the correct answer is yes. Science can explain what a manatee eats. We can observe that manatee and we can see what it's eating. We can do tests to see what it eats. All right, let's do another one here. Why won't it launch? Oh, my button for launching is. Am I still sharing that one? There, that's why. Can science explain why a manatee likes to eat water lettuce? What do you think? Yes or no? Remember, science deals with the physical world, not with things like hopes and dreams and likes and loves and dislikes and anger and fear. You know, science doesn't deal with those things. So science cannot explain why a manatee likes to eat something. It can explain that it does. It can explain what it likes to eat, but not whether or not it likes to eat it, because you probably eat some things that you don't like, right? most of the time you probably do. So you see the difference there between what science is and what science is not. Now, we want to learn to think like a scientist. That's what we're gonna process through this course. We're gonna hope to improve in this course our ability to think like a scientist. So one of the things that scientists do is they question the world around them. In order to get an answer to something, in order to figure out how something works, you usually have to start with a question. So what are some examples of questions that you might ask about, let's say, a manatee? What's a question that you might ask that could be answered by science? Something besides just what do they eat? What is a manatee? That's a big question. Yeah, but we certainly could. How do they communicate? Excellent. Good answers. Scientists ask questions that often start with these words: where, why, what if, could it, what, would it, when, and how. So those are some examples of the kinds of words that often start a question. A lot of times it's something like, what would happen if I did this? That's the kind of question that we would ask as a scientist. So here's a scenario for you guys. So I want you to imagine that you are a scientist in the African Congo. So while you're out in the field, you observe one group of healthy chimpanzees on the north side of the jungle. But on the south side, you find a group of chimpanzees that are mysteriously dying. What are some questions that you might ask related to this scenario? On the north side, they're healthy. On the south side, they're dying. Anybody? You might start with just why. Why are they dying? Yeah, what's causing them to die? But then we can even take that why question a little bit farther and maybe in our mind say, what if? So what could be different between the north side of the jungle and the south side of the jungle? How are the two environments different? How do the animals behave differently? Maybe the ones on the north side behave differently than the ones on the south side do. Those are some questions that we might ask. We also, as scientists, want to make very detailed observations. So how could we make our observation more detailed than just the ones on the north side are healthy and the ones on the south side are dying? How could we make that more detailed? What might we want to know about the chimps? What might we observe about the chimps? You might want to ask questions like, yeah, are there different plants on different sides? Excellent. So maybe there's a plant that is taking over and not nutritious. That could be something we could ask. What about the number of chimps? Maybe the ones on one side, there's a lot more. It's a very big group. And on the other side, it's a smaller group. So maybe the big group doesn't have enough food, but the smaller group does. What about male or female? Maybe it's affecting them differently. If it's only the males that are dying on one side or only the females, we're going to look at that differently. What about age of the chimps? If it's only the real old ones who are now dying, maybe the ones from the south side are moving to the north side. Yeah. Maybe we see larger numbers on the north because there's immigration happening where they're moving in. Yeah. So these kind of detailed observations can lead our questioning and can help us to design experiments that are valid, that are going to give us the answers that we want. So when scientists want to answer a question, they search for evidence using tests or experiments. So an experiment is a test that lets us see if our thoughts are right or wrong, if our predictions are right or wrong, if our what we call hypothesis is right or wrong. And then evidence makes up the observation that we do during our experiment. So let's use an example here. Let's suppose that the scientists wonder if the chimps on the south side are dying because they don't have enough food. What's a test that they could do to find out if that hypothesis is true? They think they might be dying because of lack of food. What's an experiment that we could test? Yeah, put out food and see if they survive. That's a pretty basic test that we could do. So we could put out more food, and if they start, getting healthier and not dying, then we could know our answer. Okay, Kian. So remove all the food on the north side to see if the ones on the north side die, right? So there's two ways we could test most experiments like that. We could either give more or take what they have away. Now, we don't usually take away food from animals. We don't want to go into a jungle and take away all their food. That's kind of cruel. So we try to, as scientists, behave in an ethical way that is not cruel to the animals. So we probably wouldn't take their food away. We probably would give them more on the south side and see if they survived. So scientists are often, we do what's called questioning our answers. So let's suppose we put some food on the south side and now they're not dying anymore. We notice that the chimps are getting healthier and they're not dying. We also then want to question that answer. What does that mean, to question an answer? You guys ever heard the word skeptical? Good scientists are skeptical. They question things. They never use just one piece of evidence to come to a conclusion. So maybe the chimpanzees died from a lack of food, but there could also be other explanations. They maybe died from some kind of a virus or a bacterial infection. Maybe there was some less obvious cause, like there was a poisonous plant that they were eating, and it wasn't lack of food, it was the wrong food. So giving them a different food could make them live, but it's not necessarily from lack of food. It could be something else. So more experiments would need to be done before we can know for sure. Good scientists question their own conclusions, and they find other scientists to do the same work to either confirm or disagree with their evidence. All right. Now, there's hold on just a second. So there's this Francesco Redi. Did you guys read about this yet? I can't remember if this was in, I thought so. It was last week in your lessons about how he disproved the theory that living things come from non-living things. So what did people see that made them think that a living thing could just appear from a non-living thing? What kind of things did they? Beth.
They saw flies. They thought flies were like emerging from rotting food.
Yeah, exactly. They saw these flies on rotting food and they thought, oh, the flies must just be spontaneously appearing. They called that spontaneous generation. But this Francesco Redi, he didn't think that was true. So he did an experiment. What experiment did he do? Go ahead, Hannah.
He put some of the flies in, he put a container with some meat in it and closed it, and then he put a container with meat and then leave it open. The one with the closed cap the flies weren't in that one, but the one with the open cap, the flies were in it.
Good. That's a good summary of that experiment. So he did this experiment where he covered up some of them with gauze, some of them with parchment, and then left some of them open. And he learned from this experiment that spontaneous generation is not true. His work helped to disprove the theory of spontaneous generation. So what do I mean when I say theory? What's that word mean? What is a theory? There was a theory of spontaneous generation that we disproved. So in a lot, go ahead, Beth.
A theory isn't it an educated guess?
So that's close. That's very close. That's the definition we use for hypothesis. And a lot of times we use hypothesis and theory. They're real close to each other. There's a little difference between the two, and we'll talk about what that is. But a lot of times when we hear the word theory, we think of the word hunch or a guess. But that's not what it means in science. In science, a theory is well tested, established observation or evidence. It is supported by evidence. It's not just a theory. There's a lot of facts behind something that we call a theory in science. And usually theories are developed through repeated experiments, and they're usually tested by a lot of different people. So an example would be the theory that matter is made up of atoms, right? That, you know what an atom is. An atom has a neutron, proton, and then electrons around the outside. So that is a fundamental theory of science, one of the basic theories of science. But like all theories, it could change if there is evidence to support it. But it's not going to change unless we get evidence to support it. So spontaneous generation was one of those theories that is that we've disproven. Now there's another theory here that you guys might be interested in. This is called the blank slate theory. This one was also disproven. This was really popular back in the 1600s. Basically, they said that when babies were born, they were a blank slate. They knew absolutely nothing, that they were built without any built-in mental ability, and that everything that they had came from experience of the world. Well, we know now that that's not true. They're not a blank slate. We actually all have genes that we inherit from our parents. We have heredity. You know, there are some things that you're like your parents and some things where you're different. We also have some innate things, some instincts that we're born with, and those play an important role. So this theory was disproven. But there are some theories that we still have now that we base our thinking on, that we still think are true. One important one that's true, or at least true based on what we know now, is called the cell theory. So this is a really important one. This is one of what we call the central tenets of life science. So one of them is all organisms are made up of one or more cells. If something is not made of cells, it's not a living thing. If it is a living thing, it is made of cells. And knowing that all of those are made of cells helps us to understand how they're born, how they grow, how they die. That information helps us understand why organisms take the form that they do, how diseases can be taken care of, how cancer grows, all of those kind of things, knowing that they're made up of cells. The cell theory also tells us that all cells come from pre-existing cells. That means from cells that came from another cell. So something that we don't have spontaneous generation. Cells don't just appear from nothing. They have to come from another cell. And number 3, the cell is the basic unit of structure and organization that performs life's functions. That's the cell theory. That's an important one. We'll talk about that from time to time as class goes on. So everything's made of cells. All living things are made of cells. Cells all come from pre-existing cells. And that basic unit of structure, basically what that means is the way a cell is put together decides what it does. What's inside a cell determines the way the cell behaves. And all of the cells working together give you the functions of life. Let me see how we're doing here. All right, so I want to talk a little bit more about the scientific method. So we'll talk about this a good bit throughout our course, because this process called the scientific method is used to answer questions, and it helps one scientist to reproduce the experiment of another scientist. So think about baking a cake. Why do you think it's important that you use the same ingredients in the same amounts every time you bake that cake? What if one time you used, oh, go ahead, Beth. Somebody was talking, I thought it was Beth.
So it turns out the same.
So it turns out the same, exactly. If one time you used a cup of sugar and the next time you used a teaspoon of sugar, that'd be a very different cake, wouldn't it? Wouldn't be very sweet at all. If one time you used a cup of salt when the recipe called for a teaspoon of salt, ooh, that would be a terrible cake. So you have to use the same ingredients in the same quantities or you will get a different product. The same thing is true in science. So we have this method, this scientific method that we follow in a particular order so that we can make sure that we get similar data every time we do an experiment. Now, here's the steps of the scientific method. There's a bunch of them. If you Google scientific method, you'll get a bunch of different ones. Sometimes they'll have 1, 2, 3. This one has 6 steps in it. Sometimes they'll have 7. Sometimes they'll have 8. Sometimes they'll add research here in between question and hypothesis. But this is the basics of the scientific method. First, we observe something. Then we question it. Then we make a hypothesis. Then we do an experiment. Then we analyze the results of our experiment. And then we come to a conclusion. So looking at them all individually, the first thing we do is make observations. So let's put this to reality here. Let's suppose that you get 2 slices of bread, you put them into a toaster, and you toast and you press the button down. But after a minute or 2, your bread does not toast. What is your observation? What are you observing here? Go ahead, Hannah.
The bread hasn't toasted.
Yeah, very good. Observation. The bread won't toast. Toaster didn't toast my bread. All right. The next step of the scientific method then is to question. we ask a question based on our observation. What might we ask?
Is the toaster even plugged in?
That's a good one. Yeah. So sometimes we start with something real basic like why? Why won't it toast? But we want to get as specific as we can. So Kian's response, the answer, is the toaster even plugged in? That's a little more specific. So that's a better question than just why won't it? Why won't it toast? What are some other possibilities?
The
Maybe.
toaster's
Go ahead, Beth.
the toaster's broken.
Maybe the toaster's broken. One thing that we might do now is go to do some research. We could see if someone else has had the same problem. So we could go online or we could look at a book. And, you know, if I did a Google search for why won't my bread toast, I probably would get some suggestions for that. If I said, Mom, toaster's not working, Mom might have a suggestion too for what you might do. That would be research. Then what we're going to do is put together what's called a hypothesis. So that is a potential answer. This is the educated guess idea. I like prediction better, educated prediction, because it isn't really a guess, but it is kind of a guess. Well, hypothesis is a potential answer to a question that can be tested. So in this case, we might predict that if the outlet is broken, then plugging the toaster into a different outlet could fix the problem. We always want to put our hypothesis in the form of a statement and not a question, and it has to be testable. So something that isn't testable is the toaster doesn't like this kind of bread. We can't test that. We can't test whether a toaster likes something. You know, an alien is sending a beam down from space that's preventing my toaster from working. That's not testable. It has to be something that we can test. Now, usually we're going to put our hypothesis and our prediction together in one sentence that is, if I do something, then something will happen. So in this case, it could be, if I plug the toaster into a different outlet, then something will happen. So that if then is the best way to write that. It makes it really, really useful. And sometimes it's called a conditional statement instead of hypothesis. So let's assume that our problem is that the outlet is broken. Give me an if-then hypothesis for the outlet being broken. Anybody? If we think the problem is the outlet, if I plug the toaster into another outlet, then the bread will toast. That could be a good if-then sentence for that. Now, after I've got my hypothesis and I've got it in if-then, which is really important, the if-then tells me what I'm going to do. If my hypothesis is, if I plug the toaster into a different outlet, what's my experiment? Plugging the toaster into a different outlet. What am I going to look for? It toasting the bread. So it gives me what I'm going to do and what I'm going to look for in that if-then. So if I plug the toaster into a different outlet, then it will toast the bread, right? Now, in most scientific experiments, we only want to change one thing at a time. What if we tried a different outlet and we tried a different kind of bread and we used a different toaster? Would we know what caused the bread to toast? No, could be any one of those. So we only want to change one thing at a time. That thing is called a variable. We only want to change one variable at a time. So basically the things that are involved in a scientific experiment are called variables. So a variable is anything that either can change or can be changed. So what can change is what we do, can be changed is what the results are. Now we want to change one of those so we're sure what's causing the effect that we see. So what's the variable that we're changing in this experiment? What is the one thing we're changing?
What outlet you use?
Yep, we're changing it. We're plugging it into a different outlet. That is what we call independent variable. It's the thing we change. Independent variable is the one you change. We'll talk about that more in future classes too. So sometimes the one we change can be called an experimental variable. It can also be called a manipulated variable. There's different names for it. For our class, we're going to use independent variable. Now, there's other variables that we don't change. What are some things we're not changing? The only thing we're changing, the independent variable, is the new outlet. So what else are we not changing? The bread, right? Good. The toaster. Yep. The room that it's in. The person doing the toasting. The heat in the room. You know, there's a lot of things, really basically everything else. We're going to try to keep everything else the same. Now, there's one more variable that we need to consider. We need to consider the then part. The independent variable is plugging it into a new outlet. That's the thing we're going to change. We also need to consider what we're going to measure. What we're going to measure here is whether or not the bread toasts, what we're looking for. So in our experiment, to test our hypothesis and only change one variable, we are going to plug in the toaster into a different outlet and try again. The independent variable is the thing we change. The dependent variable is the thing we measure. And then the variables that we don't change at all, we call controlled variables. Those are the three primary kinds of variables that we work with in science. Independent variable is the one you change. Dependent one is what you measure, and controls stay the same whatever. So to help you remember, I want you guys to listen to this song. We'll play this song a few times as we go through our course.
Independent variables are the ones you change. Independent variables are the ones you change. Dependent ones are what you measure. Controls will stay the same whatever. Independent variables are the ones you change.
Hey, so you guys know what the word control means. You like that one, Alistair? I like that one. So independent, you guys know what the word control means. The word control means to keep something the same, or to keep it like in a box, to keep it from changing. So you already know what controlled variables are. They're the ones that you don't change. So if you could just remember that first part of his song, independent variables are the ones you change. Now you know what the dependent ones are. They're what you measure. The if in your hypothesis is the independent variable, the one you change. The then is the dependent, or what you're going to measure. So let's look at that in this experiment here. In this experiment, we want to know if changing the amount of water affects the growth of plants. There's two different ways that we could write an if-then hypothesis for this. What could our hypothesis be? If I do something, then something will happen. Could say, if I give the plants more water, then the plant will grow taller, or have more leaves, or living or dead. Yeah, James, that's the other way to do it. If I give the plants too much water, then they're going to die. Or if I give the plant not enough water, then it's not going to grow. There's a lot of different ways to write that hypothesis. So what is our independent variable in this experiment? Independent variable is the one you change. What am I changing? The amount of water. Yep, the amount of water, the independent variable is the one that's changed. The dependent variable is the one we measure. That is what is affected by the change. All right, let's do one more. And then, you know what? I'm going to do this one for Beth. All right, let's suppose that we're interested in learning which breed of chicken produces the largest eggs. What is our independent variable? The breed of chicken. Very good. What is the dependent variable? The thing we measure. The size of the eggs. Good. Excellent. All right, let's go back to this one. Let's suppose a scientist is testing the effect of light and dark on the behavior of moths by exposing them to different amounts of light. And let's suppose that the scientist comes up with a hypothesis that says, if I expose the moths to bright light, then they will be more active. What's my independent variable? The thing I change, the amount of light. What's the dependent variable?
Behavior.
The behavior of the moths. Yeah, excellent, excellent. All right, good job. We'll do more of these next week. We'll do a couple more. I want you guys to really know what a good hypothesis is and what dependent and independent variables are. All right, I'll see you next week. In the meantime, if you have any questions, don't hesitate to contact me. Bye, everybody. Thanks for coming. Thanks for participating.